Since 1981, Brian Burt and his wife Ruth Hayward have been growing and selling plants at Burt's Greenhouses, located just north of Odessa, Ontario. In the beginning, it was just Brian, Ruth, and 4 modest greenhouses. Today, Burt's has 24 summer employees in 8 much larger greenhouses covering 60,000 square feet and another 40,000 square feet of outdoor bed space.
We grow annuals and hanging baskets and perennials and shrubs, as you can see examples here that are being overwintered. We retail our own product in 6 outlets that are spread between Belleville and Kingston. We've always been concerned about sustainability, and as an example, since 2001 we have been using biological pest control in order to control insects.
Greenhouses keep plants warm by containing radiant heat from the sun. But when the sun goes down, or in winter and early spring, solar radiation alone can't keep the greenhouse air warm enough for plants to grow. The sun needs help. To do this, Burt's pipes hot water under the greenhouses and to the outdoor growing beds. Burt's used to heat the water using a conventional oil-burning heating system, but the price of oil kept rising and heating costs soared. So in 2005, Burt's installed a new heating system that burns wood instead of oil. It was a big job, digging ditches, pouring concrete, building a home for the new system. Burt's did the work themselves. The new system immediately cut heating costs by 65%. Here's an overview of the new system. It begins here in a hangar-like building called the Dome. Inside the dome is a pile of wood chips that serve as fuel. The wood chips are burned in a furnace called a stoker, which heats water in a boiler that is piped to the greenhouses. After it passes through the greenhouses, the water returns to the boiler to be reheated. It's all a giant loop. Burt's Greenhouses has adapted this heating system in an innovative way that can benefit greenhouse operators, farmers, and the environment. Let's take a closer look at how it works, because it's the only one of its kind. We'll start with the auger. Alex English, a Burt's employee, designed and built it.
At Burt's Greenhouses, we've incorporated a number of innovations into our chip heating system. One of them is this traveling auger, which operates with a minimum of materials and power requirements. It's designed to move sideways into the fuel pile. As it does, it can rise up or deflect sideways. This deflection is picked up by a sensor on the carriage, which limits its sideways travel until it lines up perpendicular to the carriage.
After the auger scoops them up, the wood chips move along a conveyor to the stoker, which heats the water that heats the greenhouses. The stoker is where Burt's has made its most important innovations.
There are 3 areas where we've made modifications to the unit regarding air intake. The fuel comes up this conveyor and gets dropped into this bin, which meters the fuel into the combustion chamber. On top of the metering bin is an airlock, which prevents air that we don't have control over from entering the combustion area. Now there's a couple of other areas where we've made some changes, and we'll just go around here and take a look. When the unit arrived to us, it had this yellow fan and manifold on the side of it, which controlled both the overfuel and the underfuel air. We didn't like that arrangement very much. It didn't give us very good control. So we started with changes to the underfuel air. Down here is where the underfuel air is introduced. There were butterfly valves, which sealed very, very poorly, which we didn't like. So we added these gate valves, which sealed much better and allowed us to have much, much more precise control over the underfuel air. From there, we added this fan and manifold at this end of the boiler for the overfuel air, which did a much, much better job than what was there previously. We then added another fan and manifold at that end of the boiler, which did the same thing. What we then did is some other changes, which I'd like to show you now, which tied it all together. Another piece of technology is this oxygen sensor that's mounted in the flue gas stream. This is it. This oxygen sensors like this are used in your automobile. This is a relatively inexpensive one, which works very well to allow us to get similar results to what it is in the automobile, and that is controlling the air-to-fuel ratio.
You might be asking why Burt's made all of these modifications and why they're so innovative. To understand the answer, you need to know a bit more about how stokers work. In most boilers, the fuel is fed into one end of the combustion chamber where it drops onto a moving grate that carries the fuel through the fire. Air is blown in through the vents above and below the grate to facilitate combustion. The burnt fuel drops off the other end of the grate as ash, and an auger pulls it out of the chamber from below. In a furnace like this, there are actually two fires burning, a primary fire on the grate and a secondary fire above the first one. The secondary fire is burning fuel-rich gases emitted from the wood fire directly below. The gases appear as a layer of fog above the burning wood. The air quantity and placement is critical in each of these fires. If too much oxygen is blown under the grate, it causes particulate matter to rise from the burning wood and mix poorly with the overfire gases. Some of these particulates are toxic, so you want to keep them out of the exhaust system. But the secondary fire needs enough oxygen to ensure that the gases are burned as fully as possible. If they aren't, you end up with undesirable gas emissions going out to the smokestack. So balancing the overfire and underfire air properly results in the most efficient burn and fewer toxic emissions. Keeping track of all of this activity is a computerized monitoring system that gathers real-time data on oxygen levels and temperature fluctuations in the overall system. Analyzing this data over time allows Burt's to tweak the system so that it works more efficiently. The system is still a work in progress, but already it's raising eyebrows in Ontario's greenhouse industry.
Hi, I'm Jeff Lamb with Lamb Horticultural from Leamington, Ontario. And we're in the solid fuel boiler business. Some of the things that are really innovative that they've done here at Burt's are the traveling auger system. It's a pretty slick system that's been developed for smaller applications. Also, they've developed the oxygen sensor, which is a significant improvement over what's around in the market. There are oxygen sensors already in the market, but what this application is very economical. Also, they have developed a computer program to help aid in the modulation of the boiler. That is a very innovative addition to this boiler.
Burt's adaptations to its greenhouse heating system are unique in the industry. It costs less to operate than other heating systems, and it pollutes less. But there's one more feature we haven't talked about. The stoker can be adjusted so that it produces biochar, a type of charcoal that offers environmental and agricultural benefits.
Thousands of years ago, what that charcoal did then and does now is increases nutrient holding capacity of the soil as well as increasing microbiological activity in the soil. Because of the persistence of charcoal in the soil, it's tying the carbon up and not allowing it to be released to the atmosphere. This is really helping to mitigate some of the effects of global warming.
Cleaner air, more productive soil, and a tool in the fight against global warming. The seeds of a better world aren't what you'd expect from a place that grows garden plants, but that's exactly what you find at Burt's Greenhouses.